Hey, welcome back. Today we're looking at 14.1, finding limits. So before we do that, we gotta figure out what a limit is. So what a limit is the value a function approaches as we get near a value of x. So the key word here is approaches because sometimes the actual value of the function is not the limit because it doesn't approach that number, and we'll see more so when we get to the graphing stuff. Why that's true. So when we have a limit, it looks like this. So we read this as the limit as x approaches a, right? So we have the x, the arrow as approaches a of f of x, right? So whatever the function is. Now today we're going to be focusing on tables, so we can kind of see using a table the value that our function is approaching as we're headed towards a number. So let's just jump right into our example. So it says find the limit, and we're looking at the limit as x approaches 3 of 5x squared. Now, well, I shouldn't say this now, but I will anyway. If you're allowed to plug in the value, so let's say x approaches 3, right? If we're allowed to plug it in, if it's not going to break our math rules or anything like that, then we can plug it in, and then that value will be the limit. So if we plugged in 3 to x here and simplified it, that would actually be the limit for this one. But let's go ahead and verify that using our table. So I'm just gonna go ahead and use my calculator here. So we're gonna plug in 2.99. So let's do 5 parentheses 2.99 squared. So this is going to be 44.7005. So notice we don't actually have a 3 here. We just have numbers that are getting closer and closer to 3. So we're just going to see what values we get here. Let's do the same thing for 2.999. It's going to be 44.970005. Okay, and then one more time, 2.9999 squared. It's going to be 44.9970005. Okay, and then we'll jump onto the other side of 3, so 5 times 3.0001 squared is 45.0030005, and then 3.001 squared times 5 is 45.030005, and last one, 5 times 3.01 squared, 45.3005. Okay, so if we're following this, we're trying to find the value in the right hand column that this is approaching. So if we go this way and we go this way and try to meet in the middle where 3 would be, we see that this is getting very close to 45, right? And like I said earlier, we could verify this algebraically because we're allowed to plug in the 3. So if we were to plug the 3 in here for our x, right? We're going to plug in for our x. then this is going to be 3 squared is 9, 9 times 5 is 45. Right, so we just verified it by plugging it in. Okay, let's do this next one. This one's a little bit different, right? Because one of the major reasons we use limits is sometimes we can't plug stuff in. So if we plugged our 2 in here, then we'd get 2 minus 2, which is 0 in the denominator. So we can't substitute. Oops. The denominator would be 0. And then the function would be undefined at that point. Now, let's go ahead and start doing what we did last time. So notice again, we have our 2 because we're trying to find the limit of 2 in the middle, and we have some numbers that are less than, approaching 2, and we have some numbers that are greater than, approaching 2, and we're just going to plug in those values to our function and see what we come out with. So we're going to do 1.7 squared minus 4 divided by 1.7 minus 2, and we get 3.7. And then we're going to repeat it. So we have 1.8 squared minus 4 divided by 1.8 minus 2, 3.8. Same thing again, 1.9 squared minus 4 divided by 1.9 minus 2, 3.9. Okay, on the other side, 2.1 squared minus 4 divided by 2.1 minus 2. 2.2 squared minus 4 divided by 2.1 or 2.2 minus 2. 4.2. You can kind of see the pattern here. This would be 4.3, right? So if we're looking at this side and this side, we can see that these numbers are getting ever and ever closer to the value we're looking for here, which is 4. Okay. Let's try one more. So for this one, remember, again, you don't always have to do a table, because in this case, it's asking us for the limit as x approaches 2 of x plus 2. So what we can do is we can just substitute our 2 in for x. So 2 plus 2 equals 4. Okay, you could definitely verify it using a table, but that's tedious if you can just put it in there and figure out the value. Right, because there's this is not going to be undefined, or it's not going to mess with any of our algebraic rules if we substitute our 2 in there. We're allowed to do that. Okay, and then the last one for today, we're finding the limit as x approaches 0 of sine x divided by x. Again, because we have a 0 here and our x is in our denominator, if we just substituted it in, we wouldn't have an answer. It'd be undefined because our denominator would be 0. So this is kind of one of the bigger ones to remember, if you can remember, because no one wants to make a table for this one all the time. And it's going to be important in the beginning part of, well, I guess throughout calculus, those of you who are going to do that. So let's change our color here one more time, and then let's fill in our table. So we're going to do sine negative 0.5 divided by negative 0.5 is, I'm going to round to the nearest thousandth, I guess, 0.59. The next one, sine negative 0.3 divided by negative 0.3, 0.985. Oops, this top one I messed up, I think. This is going to be 0.95895959. Oops. I think I said it and then I wrote the wrong number. Okay, and then this is going to be 985, and then sine of negative 0.1 divided by negative 0.1, 998. Okay, and then sine of 0.1 divided by 0.1, 998. And I bet because our sine graph is symmetrical, that these numbers all come out to be the same thing. So sine of 0.3 divided by 0.3, 0.985 again, and then sine of 0.5 divided by 0.5 is 959. Okay, so you can see if we're moving towards 0, right, our 0 would be here. If we're moving towards that, it looks like this is getting ever and ever closer to the value 1. Okay, so using a table is probably the least ideal way to do it. There's ways to find it algebraically, though some of those algebra type problems get a little harder. Graphically, it's probably the easiest if you have access to good graphing technology. But yeah, it's the first strategy that we use to find our limit because it's very visual. You can see the numbers approaching a certain number that way. Good job today. If you have any questions, please bring them to class for next time. We can talk about them then.